if we have a smooth curve, meaning that it's well behaved, meaning you can take the derivative of it at certain points, so it's not going to be like not just 1 over x, but at 1 over x at x is equal to 0. You can't really take the derivative of that at that point because, well, it's undefined. So it has to be continuously differentiable. So basically you have to have it continuous and differentiable, so you can't have anything like a absolute value or any jumps in the curve or anything. But so it has a derivative, it's continuous, and it's non-zero. Well, I guess it could be 0, but the derivative is never 0. So when we do a line integral, we have we're integrating over some curve. We have our function, and then ds. So when we write this, we're going to go from a to b, and we usually just parameterize, meaning we give x is a function and y is a function of t, and then when we take the square root, and then we integrate with respect to t. So that's the basic formula for a line integral. Well, I guess this whole thing is equal to ds. ds, as I've learned through my studies, is the hypotenuse, I guess, of a right triangle. So it's going to be, oh, I guess I don't need the square there, the square root there. The square root of these terms. And if you're in 3 dimensions, you just add not y, that you add the z term, and then when you take the square root, you just take the square root, and that's what you get. So anyway, let's do a little example. If we have the line integral, let's say we're doing 4y cubed ds. Let's say we're doing the curve is the line from these 2 points, -3, -2 to 2, 3. So we're also going to say t is running from 0 to 1, no bigger, no smaller, 0 to 1. So first we're going to do r of t, parameterize. So we're going to have 1 minus t times -3, -2 plus t times the end point, which was 2, 3. And this is to just give us the vector equation for r of t. And this is -3 comma -2 minus -3t minus 2t plus 2t, 3t. So then we can just combine all the like terms. This is going to be plus, so we're going to have 5t, 5t, and then we're going to have minus 3, 2. R of t is going to be equal to 5t minus 3 comma 5t minus 2. So that means that we have this x term and this is the y term. Our x is equal to 5t minus 3, y is equal to 5t minus 2. So then we're going to plug 4y cubed into our equation. So 4y cubed, we're going to do 4 5t minus 2 cubed. And then we want to know our ds. So our ds is going to be dx by dt squared plus dy by dt squared plus, well, raise that to the square root. So what is our ds? So we're going to have our square root so when we take our derivative of x with respect to t, we have 5 and 5. So ds is just going to be the square root of 5 squared plus 5 squared, or the square root of 50. And we don't like that. We want to try to simplify it as much as we can. And that's going to be 5 root 2, which is our ds. Well, multiply that by dt. So now our integral is going to be integral from negative 2 to 3 I'm sorry, I did that wrong section of my notes. Because t runs from 0 to 1, we're integrating from 0 to 1, and then it's going to be 4 times 5t minus 2 cubed dt. But remember, we need to multiply by that, so I'm going to put that on that side, 5 root 2. And then what we're going to do is we're going to do a simple u substitution. U is equal to 5t minus 2 du is 5 dt, or du over 5 is dt. So then 5 root 2. Oh, also, when u is equal to 0, t is equal to, or backwards, sorry. When t is equal to 0, u is equal to negative 2. When t is equal to 1, u is equal to 5 minus 2, or 3. So now we have 5 root 2 times the integral from not 1 to, and that's really familiar because that's one of the points we have. So we have negative 2, or it looks like one of the points anyway. It seems like it's one of the points. So we go 5 root 2, negative 2 root 3, 4, and then we're going to have u cubed du divided by 5, and then cancel those out. So now when we integrate 4 divided by 4 times the square root of 2, evaluated from negative 2 to 3, cancel those out. We have root 2 times 3 to the 4th minus negative 2 to the 4th. this will be root 2 times 81 minus 16, or we have 65 root 2, which is the entire line integral. Anyway, that's pretty much it. So what we did was we had this curve which ran from these 2 points and 0 to 1. We parameterized. This is the basic formula for parameterizing it. We have 1 minus t times the initial point times t times the final point. We find all the constants. We combine. We get r of t. And then we say, okay, well, we have our components. X is 5t minus 3, y is 5t minus 2. And then we plug that into our original curve equation. We find our ds. And then we just plug all that into our integral, and we use our techniques of integration to solve, and we get our final answer. Thanks for watching.